right, so we're now going to go into, it's still chapter 9, but we're going to go into the chemical methods of microbial control. When we're dealing with this, we need to remember that these are going to be a lot of your disinfectants, things of that nature, a lot of things that we use to help sanitize and reduce the number of pathogens in the environment, which chapter 9 is all about, reducing numbers and sterilizing pathogens in our environment anyway. This one's focusing on our the chemical aspect. The first one we need to look at is phenols. Okay, phenols, try to make this focus a little better. Are going to be a certain compound. The first of which we used was Joseph Lister's that he used that was kind of carcinogenic. So we learned after a while we didn't really want to use that, but it was carbolic acid spray. It was very effective at treating wounds, and we learned a lot about them. Some types of phenols now that we use are actually what we call a bisphenol, which are two phenols put together. An example of a bisphenol would be triclosan. Some of you may know triclosan, but it is a compound that we may put on all sorts of stuff, including your garbage bags, diapers, cutting boards, all sorts of material that are going to be placed into homes to help reduce and retard the growth of pathogens until you get them. What do? They denature proteins. Disrupt cell membranes. Some examples of what they do. An example of a bisphenol that you probably are familiar with would be Hibiclens. Hibiclens is basically, now I even have some of this and I can't even think, chlorhexidine mixed in to help with cleaning your hands and other utensils that you may be using in the hospital area. And Hibiclens can be very helpful and very useful. The second one we need to look at is alcohols. These can be very effective, and some people were asking me, I had some individuals asking me about why don't we use pure alcohol? Because pure alcohol requires water added to it to be increasing its efficacy. They do denature proteins as well. And they also disrupt cell membranes. Or cytoplasmic membranes. But pure alcohol is not an effective antimicrobial agent against the denaturation of proteins. They require water. So 70% alcohol and 90% alcohol is much more effective. Now, I'm sorry I did not start off giving you the page number to start with this section, but it's 276 in your textbook. When we deal with alcohol, we want to add water. It's going to increase your efficiency. The alcohols can be great because they do evaporate quickly. However, that reduces your efficacy because if they're evaporating quickly, they're not going to act on the microbe for an extended length of time. It's great for us to use the swab over an injection surface to remove the microbes added with the mechanical action that we're going to scrub the skin. Now, also, what we have that we want to look at is tinctures. What is a tincture? It is basically an alcohol plus a chemical solution. An example of a tincture might be tincture of iodine. So if you've ever seen tincture of iodine, that is alcohol mixed with iodine. Next one we need to look at is halogens. Now when you look at halogens, remember your, I don't think we have one here in your textbook, but the chart of elements, that chart of elements, if you looked on the far right-hand column going down, there's the list of halogens about, I'd say about 3 or 4 over from that far side. They're very reactive, non-metals, and they are actual elements. They're chemical elements. They are iodine, chlorine, bromine, and fluorine. I think I got that one right. They are intermediate level antimicrobial agents. They're effective against vegetative bacterial and fungal cells, fungal spores, and some bacterial endospores and protozoan cysts, and quite a few viruses. So they're fairly effective. Chlorine, that's what we use in bleach. We know that one. They can denature proteins, including enzymes that are proteins. So they're very effective. Iodine is the first one we'll look at. Iodine is a very well-known antiseptic. We use it a lot. People might disinfect their water with iodine tablets if they're backpackers and things of that nature. Going through the woods and you don't have a lot of space to carry things, you can use iodine tablets. Also, like I said, tincture of iodine. Okay. There's also what we call iodophores. Let me make sure I spell that correctly. We also have what's called an iodophore. And those can also be very effective. Basically, that is a detergent in iodine. An example of an iodophore would be betadine. And a lot of you may have used betadine or the generic form over a period of time. Very useful for not irritating the skin and things of that nature. So very useful for cleaning up a wound and surgical prep, things of that nature. We've used them for years and years. Also to treat burns and injection sites. Chlorine. We've used chlorine for a number of years. to just disinfect drinking water, swimming pools, wastewater from sewage treatment plants, things of that nature. Very effective disinfectants, which include sodium hypochlorite. Sodium hypochlorite is your household chlorine bleach. If you're looking for bleach, you know you can reduce it way down. It'll last you forever. But if you're looking for it, a lot of times you might find it in the swimming pool section, because sodium hypochlorite is also what we use in our swimming pools. Calcium hypochlorite is another one we use a lot. Restaurants use this one, as well as the dairy industry, to disinfect utensils. And medical field may also use it for various systems, including their hemodialysis system. Household bleach diluted by adding 2 drops to a liter of water can be used in an emergency to make safe water. Water safe to drink. It doesn't kill all protozoan cyst, bacterial endospores, or all viruses. Chlorine dioxide is another form of chlorine that's a gas form, and they use that to disinfect large spaces. They used this in the bioterrorism scare of 2001 with the anthrax. I can't believe that's that long ago. To disinfect a lot of the federal buildings and things of that nature. The last one I need to look, don't forget the chloramines. A chlorine can also be mixed to create what we call a chloramine, which is essentially sorry, I'm just afraid I'm going to make this worse while I'm doing this video, and then I'm going to have to figure it out. There it goes. Okay, a chloramine, and chloramines are basically ammonia. Let me see, there it is. Yeah, ammonias and chlorine that are mixed together. Wound dressings, skin antiseptics, things of that nature may be chloramines. They're not quite as effective as other forms of chlorine, however, they are effective. Bromine is our last one we need to look at. Now, bromine, the thing with chlorine is it's not super effective in high temperatures compared to bromine. Bromine is much more effective in a high temperature setting, so we use these a lot of times for our hot tubs. So for the hot water that stays in hot tubs, we'll use bromine tablets instead of chlorine tablets. They're a little more effective. Also, your cooling towers and your water containers, you may use bromine. As well as swimming pools, you may use bromine as a substitute. I did forget, we also need to put fluorine in there. Fluorine's used to help prevent dental cavities, dental caries. So they're put in a lot of toothpaste and our drinking water. These will disrupt the metabolism in the biofilm of dental plaque. Trying to see how many more I have to go and see where I want to stop for a pause. I think I will go through one more, the oxidizing agents, because those are fairly quick, and then we'll cover the last section so you guys can get about 15 minutes per section. Oxidizing agents, that's our next one, so let me flip my page. And that puts me about halfway with oxidizing agents. Okay, so there's my next section. So oxidizing agents, examples of these would be peroxide, ozone, and peracetic acid. I'm not really going to talk about peracetic acid too much, although I will talk a little bit about the other two. The first one is peroxides. Probably your best known one is hydrogen peroxide. Great for a number of things. However, a lot of people want to put these on wounds, and some of you are going, oh no, don't do that. The reason why we don't want to put hydrogen peroxide on a wound, especially an incision site, is because it destroys cells. Well, that's great. It destroys cells. It kills bacteria. That's wonderful. However, the issue is it will also destroy your cells. So therefore, while you're trying to get cells to grow back in an area, this is going to retard the growth of your actual cells growing and will actually harm your healing. And it's going to increase scarring as well. So you want to be careful of that and take heed of that. It's great for inanimate objects, but you don't want to treat open wounds with it. Ozone. Ozone is a reactive form of oxygen. We use this a lot of times in a lot of our homeopathic studies. It's a little more common, things of that nature, but it gives air its fresh smell. A lot of European and Canadian municipalities treat their drinking water with ozone rather than treating it with chlorine. It's a more effective antimicrobial agent than chlorine. However, it's more expensive. It's more difficult to maintain an effective concentration of ozone in water, so you have to constantly be watching with that. Peracetic acid, I don't really want to talk too much about that, but I did want to mention the other two. So that is all for this this portion, and we'll cover the last 1, 2, 3, 4. The last 4, and finish up this chapter in my next segment.